Alright, algebra students, we're here with doing some quadratics today, and I'm going to do 3 problems, so keep that in mind right off the bat. If you need to skip ahead to find one of the other examples, by all means do that. But we're going to start right here on this cliff diving problem, and in this one they provided us the formula, which helps out quite a bit. And we just need to identify our terms. So we're going to have negative 16 is A, positive 16 is B, and 480 is C. So we'll keep that in mind. Now, how long does it take for Jason to reach his maximum height? So maximum height, remember, is done by finding the axis of symmetry. And the axis of symmetry is found at B over 2A. So when we substitute in our values, we're going to have the negative of 16 over 2 times negative 16. And when we simplify that, we find out that it is 1/2 or 0.5. And don't forget your units, that is seconds. So Jason will reach his maximum height after half a second. Now, what is the highest point? Well, this is the x value. That's what we just found. Or this is our t value. So now that we've found t, we're going to plug t back into h of t. So we're trying to find the height at half a second so by substituting this in to our function, we're going to find out what it equals. That's 480. So come over to the calculator and we're going to do negative 16 times 0.5 squared plus 16 times 0.5 plus 480. And we hit enter. So we find out that his maximum height is 484 feet. Alright, now finally, we're going to find when he hits the water. Now, the water we're going to assume is what we're going to consider zero level or ground level. So it has a height of 0. So in this case, if we're trying to find a 0, we've got to use our old friend quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we do our substitution, we're going to find out, see b, so we're going to have the negative of 16 plus or minus the square root of 16 squared minus 4 times a is negative 16 again. C is 480. All over 2 times negative 16. So let's do the calculator work. Of course, first off, to do the fraction, alpha y equals number 1. and then just type it in as written, except for we can't do the plus or minus. So let's look at doing just the plus first. So negative 16 plus square root squared minus 4 times negative 16 times 480 all over 2 times negative 16. So right here we're going to find out that t equals negative 5 seconds, or, now here's the great shortcut if you forgot about this on your calculator, second enter, and now we can just go back to the plus sign and change it to the minus, or t equals 6 seconds. And right here we've got to keep in mind that we currently don't have means for going back in the past, so the t equals negative 5 seconds is not an acceptable answer unless you've got a DeLorean and you're going to go 88 miles per hour, and most of you are too young to understand that joke. But just realize that we can't go back in time, so t has to equal 6 seconds is when he's going to hit the water. Alright, so we're going to move on down, check out another problem here really quick. And on this one, I just want to set it up because you can use the processes from what we just did to solve this one. But I just want to help you realize what various things are in this one so that we can set them up. So we have our h of t is negative 16t squared plus, and then it says v of t. V stands for velocity. And I want you to notice that our initial velocity was 116 feet squared. So as a result, we're just going to go 116t because that was the velocity. And then we've got to pay attention to our h sub 0. H stands for height. The sub 0 means the initial height. So in that case, we're launching from the top of a 101 foot cliff. So then we're going to be 101 feet up, so that would be our initial height. So right here, you now have your A, your B, and your C, and you can use your quadratic formula as they told you and figure out how many seconds it would take until the rocket would hit the ground. So good luck with that one. Just wanted to help you get that one set up. And we're going to do one more setup problem just because I do want to address it all the way down here on number 11. So we initially have a trebuchet, which is just a fancy catapult type thing. If you've not watched Lord of the Rings or any old medieval movies, it's like a giant sling. But anyway, it launches projectile in a parabolic arc, okay, at 35 feet per second. Again, this is going to be our velocity, so pay attention to that. Now, using the function, and they give us the same one we just worked with, determine when the projectile will reach a height of 80 feet and how long or how many seconds later will it again be at 80 feet. So, just to give you a visual, we've got this parabolic arc, and then you've got this 80 feet. So they're wanting you to figure out how long it took to there and how long it took to get here, which is not too terribly hard, but getting the initial setup can be. So looking at this, we've got h of t equals negative 16t squared plus initial velocity, 35 feet per second, so 35t. Now, this is a trebuchet, and since they don't mention it, more than likely it's on the ground. We're just going to assume it's on the ground. So that would be an initial height of 0. So if you need to do plus 0 here, you can. I'll kind of do that phantom 0 just so people can see that there is a 0 there, but it's not really there. And then what we're trying to find is that it is at 80 feet. So 80 is going to equal all of this. Now, in order to find a 0, in order to find use our quadratic formula to do this, what we're going to have to do is make sure it equals 0. In order to do that, we've got to subtract the 80 on both sides. Not 88, 80. So now 0 equals negative 16t squared. Plus 35t minus 80. And once you get to this point, then you can do your quadratic formula again, and as a result, find the 2 times the zeros in this case, and I'm putting air quotes around that for all of you that, of course, can't see me. Because all we've done is we've shifted the floor up, and now these are our zeros, although not really. We're just finding where the height's 80. So use the quadratic formula, find those answers, and that provides both answers to the question. So good luck with this, and I hope you're able to find success.